So, in front of you and me, we have a nasty little Roberts Rambler. And the story behind this project was that somebody in the messenger group that I'm a member of was asking if it was possible to buy a portable radio that would pick up the 60 kHz time signal, which is used for clocks and watches, the setting of them in the UK. And just so happens I have one. That is a Casio Waveceptor, and it works very nicely and it's always perfectly accurate. So I replied to this person, I don't think you'll get a portable radio that will do that. I have radios that will receive 60 kHz, but they're certainly not portable. So my idea was to see if I could modify this Roberts to get it down to 60 kHz using the long wave band. Now there's two parts you have to change on to do that. You'd have to shift the local oscillator, and I think the local oscillator is around 470 kHz. No, the IF is around 470 kHz. So you have to get the local oscillator to 530 kHz. The difference being 60 kHz, I think. Yeah. And the other bit you've got to do, you've got to resonate the antenna coil on the ferret. Now ferrets don't like being messed around with, but I managed it anyway, and the results aren't great, but it works. So I'll just take it apart and show you how I've done it. Right, now this is the guts of the Rambler, and the first problem I wanted to tackle was the local oscillator, which is tuned by this capacitor, and there's also a red coil which is part of the oscillator circuit, red transformer, whatever you want to call it. So I basically stuck, I think it's, let me zoom in on it, 1.2 nanofarad capacitor across the normal tuning capacitor, and that shifted it right down to what I wanted. But I also adjusted the oscillator coil to get it spot on, and if I connect a scope to it, and I think what we need is, that's earth, and that'll be the signal. Get my scope set up. I'm having trigger problems with the scope. I'll get back to you. Okay, so it's the best I can get it, but I don't know if you can see that. Oh, wrong pointer as usual. But the frequency's reading, well, it's jumping around a bit, but it's around 530, 550 kHz. So that's a local oscillator, which should move. Well, it doesn't move much anymore when I tune it, but anyway, so that's what the local oscillator looks like. Now I'm going to turn the scope off, and the other issue was the long wave antenna coil on the ferret, and I had to stick all these capacitors across one by one till I got the right value to resonate it, and it came out in the end at 2 nanofarads of extra capacitance across this coil, and that seemed to get it spot on, although it does help to move your coil on your ferret to get it exactly on resonance, which I've done as well. So what I'll do now is show you how I tested it. So up there we have my signal generator generating 60 kHz minus 27 dBm, and it's modulated, amplitude modulated at 50%, 1 kHz tone, and that is connected to another long wave coil on a ferret, and I put the ferret and the coil some distance from the radio, turn the volume up, and you can hear it quite clearly. And if I change the frequency of the signal generator by 1 kHz steps, you'll see the difference. That's down to 58, back to 60, 63, back to 60, and that is more or less spot on. But the best way to tune it really is using the oscillator coil. So there you go, that's how you do it. And I did notice though that the sensitivity is down considerably on what it was before I buggered around with it, this radio. I suspect that you need more coils, more inductance on there and less capacitance. What else do you need? I think you need more coupling on the coupling coil, because there's a low impedance coupling coil that goes into the first mixer amplifier. I think you need a bit more on there as well. So in theory, if you could be bothered and rewinding this coil and the coupling coil also, then you probably get more sensitivity out of it. But I'm not going to spend any more time on it. It was just an experiment. So now we'll take it in the house and you can actually listen to the signal I'm receiving, which is not strong, because years ago the transmitter used to be at Rugby, 50 miles away roughly, and it was a massive signal here. Then they had some stupid idea about moving it to Cumbria, 300 miles away, and now it's a bit of a struggle sometimes to get a decent signal. And in fact my clock up there, that does often struggle to get a decent reception, especially with all the noise in this workshop, which is why I'm going to take it in the house to show you it working properly, because there's just too much noise being generated by all these bloody switch mode power supplies in this workshop. So back to the house. So here we are, back in the lounge, away from any major noise sources, and let's turn it on. Not very loud, but I think the sensitivity is down quite a lot. But you can clearly hear the time signal pulsing on and off once a second. I think there's a bit of interference from another station, which is, I think, transmitting FSK, but the selectivity isn't that great now after I've modified it. Okay, well that's the end of that video. Bye for now.